Hello, Namaste, Konnichiwa. Welcome to Sunny Sensei. In this lesson, we will prove this fundamental equation. Vf equals Vi plus A times Tf minus Ti. This equation is valid only for constant acceleration, UAM. I will first prove this using a velocity versus time plot, the graphical approach, and then prove it again using calculus. Let's start by plotting velocity against time. Velocity on y-axis and time on x-axis. Here is the plot. At ti, the velocity is vi. At tf, the velocity is vf. The acceleration is the slope of this velocity time plot. This plot is a straight line. So, the slope or the acceleration is constant. On this plot, acceleration across any 2 points, these two in our case, is the change in velocity divided by the time taken for this change. A is delta V by delta t. Delta V, or the change in velocity, is Vf minus Vi. Delta t is Tf minus Ti. Therefore, multiplying both sides by Tf minus Ti. Finally, Vf is Vi plus A times Tf minus Ti. Let's prove this again using calculus. Acceleration at any point on this plot is simply dv by dt, or integrating both sides. Integral of a dt from ti to tf equals integral of dv within limits of vi and vf. Acceleration is constant, so we pull it out. Integral of dt is t. Integral of dv is v. Solving further, finally, we have Vf is equal to Vi plus A times Tf minus Ti. To understand this equation further, let us look at a simple problem. A rock is dropped from a certain height. The rock reaches the ground in 12 seconds. Assuming no air resistance, what will be the velocity of this rock after 5 seconds? So we start with the rock. It is held above the ground. Initially, at time 0, its velocity is 0. We need to find the velocity of this rock after 5 seconds. Time is 5 seconds. Velocity is unknown. The rock reaches the ground in 12 seconds. Time is 12 seconds. What else do we know? The rock is falling under the influence of gravity. So, the acceleration is the acceleration due to gravity, plus 9.8 meters per second square. We have assumed that the downward direction is positive. Acceleration due to gravity is constant. So, this equation is valid. Vf, or the final velocity, is v2. Vi, initial velocity, is 0. Acceleration is 9.8 meters per second square. Final time is 5 seconds. Initial time is 0. Solving further, the velocity of the rock after 5 seconds is plus 49 meters per second. Plus indicates that this velocity is in the downward direction. We have solved the problem. Still, for better understanding, let us look at this plot. Velocity on the y-axis, and time on the x-axis. The acceleration is plus 9.8 meters per second square. For every 1 second, velocity increases by 9.8 meters per second. At time 0, velocity is 0. So, at time 1 second, the velocity is plus 9.8 meters per second. Constant acceleration means constant slope. We can connect these 2 points and extend the line further. This is our velocity time plot. For time at 5 seconds, velocity is plus 49 meters per second. We get the same result as before. Velocity of the rock after 5 seconds is plus 49 meters per second. Before we conclude this lesson, here is a simple challenge. What will be the velocity of this rock just before it hits the ground?